Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6 and we will present our process simulation project on metallosynthesis. My name is Wan Fatina Atika binti Wan Arid and my friends Nur Shazal binti Azhar and Nurul Aina Shahira binti Karolizam. First, I will start with the introduction. Methanol is a colorless, volatile and flammable liquid. It is used in ship fuel and the production of methyl third butyl ether or known as MTBE and as well as as a feedstock in petrochemical industries. Methanol is produced from the conversion of synthesis gas, also known as syngas, by steam reforming process. The catalyst used in this project is nickel solid, and the fluid package used for this methanol synthesis is Peng Robinson. Our desired product is liquid methanol with the purity of 98.9%. Next, I will show you the improvement that we have made in our process. In the part 1, we use partial condenser in the distillation column. As there is a lot of carbon dioxide vapor, so we are required to add recycle stream at the condenser to recycle the excess carbon dioxide in order to increase the production of methanol. However, as we did the overall HYSYS simulation, we found that by adding energy stream at the flash tank V101, we could increase the temperature from 38 degrees C to 82 degrees C. And most of the excess carbon dioxide can be recycled at the top of the flash tank. So the recycle stream at the distillation column can be omitted. And the operating cost can be reduced. Total condenser can be used to have a fully liquid methanol as the distillant of the distillation column. Next, as we found that there is a little amount of methanol at the bottom of the distillation column, we added a T101 to further split the methanol and water. We are able to achieve a methanol purity of 98.9% despite of changes that we have made in the process. We will show you the overall HYSYS simulation for methanol synthesis. First, the feed component or the mass fraction of feed component is added in the stream 1 with the composition taken from the Lieben 2010. The inlet temperature is 50 degrees C and the pressure of 51.2 bar. The stream 1 will enter the compressor K100 in which it will increase the pressure from 51.2 bar to 75 bar with as well as increase the temperature to 98.86 degrees C. The temperature of the stream 2 will be reduced in the cooler E100 with the pressure drop of 10 bar. So it will come out the temperature outlet will be 38 degrees C with the pressure of 74.9 bar. To further increase the pressure, it will enter the K101 in K101 to increase the pressure to 110 bar with the temperature of 84.21 degrees C. The mixer 101 is to combine the stream 4 and stream number 4 and stream number 21 in which it is a recycle from the separator and flash tank to produce stream 5. The stream 5 will enter the feed effluent heat exchanger with the temperature of 115.3 degrees C. In the reactor ERV100, there are two reactions that are occurring inside it, and both reactions are exothermic reactions. The reactor effluent in which in the stream 8 with the temperature of 273.9 degrees C will enter the FHE and transfer the heat to the cool stream from the stream 5 to produce stream 6 in which the temperature of stream 5 is increased in the FHE to produce temperature with a new temperature of 144 degrees C. The stream 6 will further heated inside the reactor preheater E102 with the E1O2 until it reached the temperature 150 degrees C, which is the operating temperature for the reactor. Uh, and also in the stream 8 also being cooled in the FUHE to produce the temperature of 244.8 degrees C in the stream 9 before it being further cooled inside the cooler E103. In actuality, the stream number 10, there are no flow inside it.
The component will enter the cooler and it will cool down the component to 38 degrees Celsius. This temperature was specified based on our reference Leuven, and then the component will enter the separator. In the separator, energy stream were added, and the stream 13, the temperature was specified to 100 degrees Celsius. And then it will enter the valve, and the pressure at 17 will be 200 kPa. Stream 17 will enter the flash tank. In this flash tank also have a energy stream. And then at stream 22, the temperature was specified to 82 degrees Celsius. The stream 22 will enter the valve where there is a pressure drop of 50 kPa, and the stream 23 will enter the distillation column. From the top of these two separation unit, it will be recycled back to FHE. From the top of separator, stream 14, it will enter a T, which will split the stream into two, which is one of vented stream, and the stream 15 will be recycled back. Stream 15 will be enter the compressor, and then stream 18 also will enter the compressor to stream 19. This stream 16 and 19 will be combined in the mixer to create one stream, which is recycle stream, that will need to recycle back to the heat exchanger.
For the distillation column, there are one inlet stream and two outlet stream, which indicate the top and the bottom product of the column. Stream 23 enters the 20 stage of distillation column at the stage of 10 after the light component is being removed through the flash tank. In stream 24, the purity of the methanol is high. As you can see, the purity of methanol is 99.65%, but we didn't take it as our final product because there is more methanol is being removed at the bottom of the column. The bottom outlet is then undergoing splitting by using T101 to split the methanol and water to finally achieve our purity product, which is 98.9%. The liquid methanol is then stored in a storage tank with a condition of temperature 59.8 degrees C and pressure 1 bar. As for this project, two specifications has been set for the column, such as methanol recovery at the top of the column 99.9% and water recovery at the bottom of the column 98%.
Next, for the separation equipment, in the process, we have used three separation equipment, which is separator, flash tank, and distillation column. For the separator, it is used to separate light component, which is hydrogen, nitrogen, carbon monoxide, carbon dioxide, and methane. This separator is sufficiently separate most of light component at the top of outlet stream. It can be seen from the mass fraction at the top outlet, which is for the methane, it is 31.54%, carbon dioxide 30.52%, carbon monoxide 11.03%, and hydrogen 7.7%, and lastly nitrogen 7.65%. From this, the efficiency of the separator is 81.1%. The second separation process takes place in the flash tank. In this flash tank, most of the light component was separated. The efficiency of this flash tank is 68.75%. There were only 0.08 mass percent of carbon dioxide at the bottom of the outlet. The other component at the bottom of outlet is methanol, which is 88.69%, and water, 11.22%. The light component that produced at the top of the flash tank will be recycled back to FHE. Lastly, distillation column were used to extract methanol from water. There are nearly no light component inside the distillation column. The efficiency of distillation column is 88.91% with 20 stages tray were used. At the bottom of distillation column, 99.2% water was removed. Meanwhile, at the top of distillation column, methanol purity were achieved at 99.65%.
I will continue with the recycle and purging system in this project. In order to produce the methanol synthesis, separator is used to separate the inert methane and nitrogen before entering the distillation column. The top outlet stream of the separator will undergo splitting in T100 to split other component with inert methane and nitrogen. Inert methane and nitrogen will be vented off from the process as shown in stream number 12. Then, the bottom outlet from the separator will enter the flash tank to remove the light component before entering the distillation column. The light component existed due to high pressure in the separator. Moreover, the light component is being removed because it could be built in the condenser and blanket the condenser. With that, high pressure or low temperature will be needed in the condenser and require expensive refrigeration. Then, the top outlet of the flash tank will be mixed with the outlet from T100 to be recycled back to the feed effluent heat exchanger as a raw material. In the recycle stream, most of the carbon dioxide is recycled. From this, cost of the process can be reduced. Next, safety and waste minimization is very important in every process that involves hazardous chemical. Each of the chemical has their own safety data sheet that include the way of handling the chemicals and safety precaution that can be made in order to handle the chemicals. For the waste minimization, we followed the hierarchy which involve 4 techniques which are prevention and reduction, recycling, treatment and disposal. Prevention and reduction is the most preferable technique and disposal is not advisable at all to apply because it might harm the society and environment.
Okay, as a conclusion, the simulation of methanol synthesis production was successfully converged. Therefore, 98.9% purity of methanol is achieved. Some changes also were made in our process flow diagram, which is we have replaced the partial condenser in distillation column to a total condenser. Hence, from that, 3 recycle streams are reduced into only 2 recycle streams. Then, in each unit of separation equipment, the desired components are effectively separated. Lastly, as a safety consideration, a few control systems are proposed to be included in the process. That's all from us. Thank you.